Okay, lesson 4, last lesson of chapter 12. And so far we've been talking about forces and how they affect motion. And so this lesson, we're just going to be identifying some common forces that are around us in our everyday life. So the first one is friction, and I'm sure you may have heard of this before, and maybe if you haven't even heard the word, you've definitely seen the idea. Basically, friction is the force that opposes the motion of two surfaces that are actually touching each other. And so if you're rolling something on the floor, friction is the force that's going to work against the rolling. So that's what it means by opposing motion. So the amount of friction between two surfaces depends on two factors. Please remember these, underline them, star them in your book somewhere. The kind of surfaces, because obviously rolling on a smoother surface is going to have less friction than rolling on a bumpy surface, right? And rolling on a slick surface is going to be less friction than rolling on a sticky surface. So the type of surface definitely affects the friction, but also the amount of force pressing them together, right? So if you are pushing two plates really hard against each other, it's going to be a lot harder to move them than if they're like gliding past each other, right? So type of surface and the pressure on the surface. Those are the two things that can really affect friction. So we have a couple different types of friction. The first one is static friction. So when you think static, think something's like not moving. Just in general, when you hear that word. So when you have static friction, this is a force that's preventing two surfaces from sliding against each other. So you're trying to push a bookcase and it's not moving. Maybe it's because the mass of the bookcase is too big for you. Maybe it's because the friction of the floor is just making it really hard for that surface of the bookcase to move. But for whatever reason, the force that's working against the motion and keeping something still is static friction. Sliding friction is the force that moves against two things that are sliding past each other, right? So if you have something sliding across your floor, again, the force that's going to stop it from moving eventually is that sliding friction. And then you have rolling friction. We tend to use the term traction, but rolling friction is whatever prevents something from just that, from rolling. So when you have tires, you want some sort of traction, right? Or you don't want to be rolling uncontrollably. That force between the surface and the wheel, or whatever's rolling really, is your rolling friction. Air resistance is similar to friction, but it's not really a surface, so we call it air resistance because it's in the air. Sometimes you can hear this referred to also as fluid friction when you're talking about a liquid or a gas, but it's the same idea. There's motion opposing something. If it's an actual object in the air, like the paper bag in the picture here, we'll call it air resistance because there's an object whose motion is being resisted. If there were like two different gases moving past each other, we would normally call that fluid friction. But I'm just telling you, don't be surprised if someone uses them interchangeably. So then we have gravity. We've talked about this quite a bit when we were talking about planets earlier. And remember, everything has a gravitational pull. Anything that has mass, it's just things that are so small, it's not great enough to notice. So no, you don't have something orbiting you, even though you have a gravitational pull. Some other things that are important to remember about gravitational force is the closer the objects are together, the stronger the gravitational force. And also, the mass affects gravitational force. So like we just said, things that are smaller, some will not have enough pull to pull something near it. But even if we're talking like planets, right? A smaller planet is going to have a weaker gravitational force than a larger one. Then we have centripetal force. Centripetal force is the force that basically pulls something towards the center when it's moving in a curved or circular path. So remember we were talking about planets orbiting, right? and we said that there were two forces. So if you just look at this diagram over here, the blue arrows would have represented the gravity, right? That's pulling whatever that's orbiting, whether it's a moon, whether it's a planet orbiting the sun, whatever it is, the gravity of the center is pulling it inward. But that inertia is keeping it moving around. True. Centripetal force, though, is another force that keeps it moving towards the center. So if there was no other opposing force that would keep it on its path, like maybe a bar on a carousel that's going to keep it in place, or again, the inertia that's going to keep it on its path, it will move towards the center. Then we have magnetic force, and I'm sure most of us have played with some magnet before, and we understand that opposite poles attract and like poles repel. This has to do with the arrangement of the actual dipoles, is what we call them, but it's the way that the atoms are arranged inside of the material, which is why some things are magnetic and other things are not. Think like nickel, that's and cobalt, those are substances that their atoms can line up so all the positive ends are near each other and all the negative ends are near each other. So it's really easy for them to interact with magnets. But similar to gravity, the closer you are, the stronger the force is going to be. The further away you are, the weaker it's going to be. Mechanical force is when you're actually, think of like mechanical work, right? Like you're working with your hands, you're actually physically contacting something. So sometimes people will interchange like contact forces. Remember we talked about contact and non-contact forces, and a mechanical force. So if you're actually physically in contact with something, and it's forcing it to be pushed or pulled or forcing it to stay in motion, that's a mechanical force. Electrical force is similar to magnetic force in that it has to do with the arrangement of atoms and positive and negative charges within atoms. It has more to do with transferring of charges, though, which we'll talk more when we get to electricity, but it's similar. It's electrical charges between two objects interacting with each other. And then we're going to finish with nuclear force. So we didn't talk a whole lot about the structure of atoms this year. We're going to be talking about that a lot more in 8th grade when we do chemistry. But nuclear force is what holds together the nucleus of an atom. And in the nucleus of the atom, you have protons and neutrons. So that is the force that holds your atoms together, basically. And that is chapter 12.